I'm Tim Ventura, and we're joined today by Dr. Chance Glenn, Professor of Electrical Engineering and the Provost and Vice President of Academic Affairs at the University of Houston, Victoria, and the founder and chairman of the Morningbird Foundation. Dr. Glenn has decades of experience in engineering, technology, entrepreneurship, and higher education. He's published extensively, holds patents, and traveled globally to speak on issues of science, innovation, and technology. Dr. Glenn holds a bachelor's degree in electrical engineering from the University of Maryland and a master's and Ph.D. in electrical engineering from the Whiting School of Engineering at Johns Hopkins University. He also holds a management development certificate from the Harvard Graduate School of Education. So, Chance, welcome. It is a pleasure and an honor to have you with me today.
Thank you, Tim. I got to give you a little update, on my bio, and probably not the latest that you have, and that is I'm a faculty member in electrical engineering at Alabama A&M University. So I'm back to teaching and research, which is really has been really a blessing regarding what we're going to discuss, because I've been able to really dive deeply into some of these really deep and meaningful scientific endeavors as a faculty member now, and kind of stepped away from academic, at least from administration at the moment. So just wanted to correct that.
No, that's awesome. And, it's exciting that you are doing real hands-on experimental work. Yeah. And I know, what we're talking about today, this is not the only experiment that you've been conducting recently. But it's...
and we can get into whatever you like. I got a couple of things that, and a lot of it's kind of running through the company that we have, which is called Morningbird Space, morningbirdSpace.com. You can see all what we're into, and the most interesting stuff I think we'll get a chance to talk about today. So I'm in your capable hands, and we can go into things however you like.
Let's roll with it. So today we're talking about the experimental Spacetime Distortion engine. Yeah. This is a new project that you've been working on that generates interference patterns that are indicative of spacetime distortion and helps to validate speculative theories that you've been working on.
Yes.
So I'm wondering, can you start us out with kind of an overview of what the actual experiment is and the results that it produced that are so exciting?
Okay, well, let's see. The best place to start is, I think at the moment, a lot of us are familiar with Dr. Alcubierre's work to basically mathematically show that if you could provide energy and energy density of a certain form, then you could distort space-time. And that was this Alcubierre metric, and what has happened. Dr. Sonny White has kind of added to that with talking about how to reduce the energy requirements. However, the one big roadblock in all of it was that the requirement was for negative energy density. Now, my first foray in sticking my toe into this whole thing, number one, I'm very interested in science fiction. I'm a big Star Trek fan. I've always looked to try to develop technologies that had something to do with Star Trek, all that. So obviously warp drive caught my interest. And I looked at the outcome, some of the results from Dr. Alcubierre's work, and introduced this idea that if you had a complex shaping function, and that being having a real and imaginary part, with the imaginary part being greater, then if you work through the math, the energy density requirement would no longer be negative. That was my first, and mathematically it worked. And then I began to concoct an experiment, because I found a material that had a complex dielectric constant, is a material called ethylene glycol. And electroengineers don't like this kind of stuff because it's lossy. But what it did was show that the energy density values would turn from negative to positive. Now, in the experiment, I was not able to generate enough power and ultimately energy density within this chamber that I concocted that held this material in order to get anywhere close to even showing that this would work. But again, mathematically, it is a solution. So then I started to think about, well, what is a way to increase the energy density? And that is, energy density is about putting a lot of energy in a really small volume of space. And the higher the more you do that, either the smaller space or the higher the energy, that's how you increase the density. So I started thinking about ways to do that, and a spark gap came to mind. Because you can generate very high energy levels, but also if the area or the volume of that space where the spark is formed is small, then the energy density. The other thing I discovered through the equations is that the negative energy density fell out of Alcubierre's treatment because he was trying to both compress and expand space-time within this same quote-unquote bubble. And in the back, you're expanding space-time, and in the front, you're squeezing it. Now, compressing space-time happens within nature all the time. That's what gravity and matter does this. Mass does this. It compresses space-time. It is the expansion of space-time that calls for this negative energy density. Now, you could make something move by either compressing or expanding space-time. So let's just try compressing space-time with a lot of energy density. And that is what led to the experiment. And so this experiment has, in order to try to detect whether space-time had been distorted, we needed an interferometer, a laser interferometer, which is a benchtop type of, almost think of some of the LIGO experiments where they detected gravitational waves, now compress that down to a desktop. It's just the interference of a laser beam with itself. And if you can alter the distance that the laser travels, it will show up in the interference fringes. That's the experiment. So being able to do that, and I was able to set up an experiment with both a 650 nanometer laser and a 537 nanometer laser, and did those. Now, just to note, and I've been talking a lot. I mean, if you want to jump in with questions, I'm, but with this laser, I've been able to, with these lasers, been able to provide interference fringes with both of those wavelengths. And that was very important to do both of those wavelengths because that was going to allow us to mitigate some of the other factors that could contribute to the movement of the fringes. So you're looking for fringe movement as you're applying the energy, and those fringes move. There's only a few things that could account for such a thing, and vibration obviously is one. But one of the things that we really had to overcome was index of refraction change. That was one thing that we had to, and that's why, number one, we used the two different laser wavelengths and showed, and I have a paper that has this entire experiment. It should be coming out any day now in the European Journal of Engineering and Technology Research. That's the name of the journal. You should be able to find it by Googling that name. And I expect it to be coming out this month. But that paper shows that the results of the fringe movement as we increased or decreased the energy density. Now, first of all, let me say that the energy density levels were on the order of 10 to the 12th joules per meter cubed. The literature showed that around this area is a place where you could begin to see distortion of space-time. And then, so not only did we have two different wavelengths, we also repositioned or the orientation of the laser with the spark. So if you can imagine a spark, kind of, and for those who are watching, I have two fingers held up, and the spark is between those two, and a laser going directly between that at a 90 degree. We call that 90 degrees. Now, if the spark is in the same direction as the laser beam, then that would be 0 degrees. And we changed that orientation to see what differences we saw in the displacement of the fringes. And we did see displacement, which was a huge thing anyway.
And so let me jump in for just a moment.
Please do.
So again, actually the way that you've been explaining it is very detailed. I want to try and break this down and streamline it for the audience. So you're starting out with basically an AC signal generator, and you're stepping that up to a high voltage. You're pulsing that through a spark gap, and that is creating birefringence patterns with a laser interferometer.
Well, the only difference I'll say is that it's not AC per se. It is it is modulated, though. It is a pulse that we can modulate and change its pulse repetition rate.
Okay.
And that, you know what? And it's good that you brought that up, because that part is very important. Because my whole premise is that it is the change in the energy density from, say, 0 to whatever it is. That change is what initiated these gravitational waves that we believe we observe.
And that, again, you've done experiments in the past with ethylene glycol, and that was reminiscent of bubble fusion, right? Which is the similar thing. You're trying to increase that energy density. As those bubbles collapse, you get these incredibly high pressure areas, right?
Well,
and so that...
Well, the key for me for the ethylene glycol was that it has a complex dielectric constant. And it had a dielectric constant that had a higher imaginary part than real part, so that when you squared it and it went through the mathematics, it got rid of this negative energy density. And from a practical standpoint, this was inside of a chamber that then we pumped with RF, and that was AC RF signal. But I moved away from that because I couldn't get the density, the energy, power levels high enough to get anywhere near where I thought we would see the fringe or the changes in the interferometer. So that's when I went to the spark gap.
So let me head folks off at the pass in terms of the Alcubierre drive. I'll provide a little history there as well. And the reason I say that is, the Alcubierre drive was in 1994. Dr. Miguel Alcubierre quite literally set out to create the physics to make the Star Trek warp drive real, right? That is the inspiration for the Alcubierre drive. Yes. And as I think everyone knows, and as I've often heard as a rebuttal, people say, well, it requires incredible negative energy densities to make this work, right? Now, in theory, within the theory of general relativity, the Alcubierre drive compresses space in front and expands space behind it, and that geometric deformation is what creates movement. Yeah. And it has a number of advantages. You could potentially travel faster than light because within the bubble you're still going, below the speed of light. You're just modifying time-space. Yeah. Again, this negative energy has been the hang-up that people push back on. Yes. But one of the things that I have seen, because I cover a lot of science and technology, is there have probably been 10 or 12 peer-reviewed physics papers that have different workarounds for that negative energy. Yeah. Now, some of those take it down to small levels. Others eliminate it entirely. And I've seen a lot of different approaches to doing that. One of the ones that comes to mind was basically spinning that warp field. And the idea of spinning it itself was able to completely eliminate the negative energy density. But, there have been many, many different approaches.
There's a guy named Philip Lenz who's I've worked with, who's been taking that rotational approach, and he really knows what he's doing. We're going to be doing some work together. But let me say that again is my understanding. I'll just say my learned opinion that the necessity for the negative energy is due to the idea that you want to expand space-time. And everyone who's taken this treatment around Alcubierre's work has made the assumption that you must both expand and compress space-time. I'm saying that you don't have to expand space-time to move. I mean, gravity causes us to move because we fall into the well. So if you were able to produce a gravitational well right in front of your ship, you would be drawn into it.
That's enough, right?
But then if if it's connected to your ship, it's going to keep pulling you along.
Yeah, no, I think that is a brilliant insight. So really what you're if I'm interpreting this correctly, I don't want to put words in your mouth, but what you're saying is instead of having to contract it in front and expand it behind the ship, all you have to do is contract it and create a gravity well in front of the ship. Space-time is naturally going to expand and fill in the gap in the vacuum, right?
Or it's going to draw you in, just like any gravitational field, like the Earth and anything else draws you to it because it's created a well that you must fall into. So we're saying if you just create a well in front of your ship, you're going to fall into it, and you just keep falling towards it. You never actually in it, and you can propel yourself forward. And as you stated, when you're talking about traveling faster than the speed of light, it is understood that space-time and its distortions and movements can travel faster than the speed of light. It's just the physical objects within it that cannot. So if you can do that, then there's potential. But even just being able to have any kind of propulsion at all based on this would be very revolutionary because it's propellantless. And if it's directly related to the energy density you're able to create, then you can scale it. Eventually you can scale it.
So in terms of creating an asymmetry for propulsion, right? Because again, we have to compress space in front of it. Do you think that this spark gap apparatus points a direction forward in being able to say, okay, we're going to take some kind of future modified variant of this? Would that be compressing space in front of the craft?
That would be my approach. I just think that it is the negative energy density is required for the expansion. And since we at this point don't know what negative energy density is, we can call it exotic matter all we want to, but that doesn't mean we know what it is. Or you could take the approach I started with and try some sort of modified material that could then, and maybe that is your exotic material right there. But I do think this simplifies it quite a bit. So I would say that would be the approach. But, I'm also, is a key point I want to keep going back to, and that is, and I call du dt, where u is the energy density. The change in the energy density, I believe, is what initiates a gravitational wave that emanates from the center. And by quickly, and that's what happened, these pulses are, and I can control the modulation, meaning the repetition rate of the pulses, control that, and you see the spark, the interference fringes moving in relation to the change of the energy density, not necessarily its static presence, but the initiation of it. That's when you see the fringes move.
Now, what kind of voltage and wattage are you running through this? What kind of
Well,
actual energy levels?
And you rightly pointed out there a transformer to step up the voltage. We're stepping up the voltages to around 400,000 volts
Okay.
at the gap. But you know the current on like probably like a half an amp or so across that
So
gap.
that's a lot of energy.
It's a
then.
lot. It's a lot of energy. But now you're talking about a gap that's probably 2.5 millimeters wide, a half a millimeter in diameter. So that's a very small volume. So now you develop that's in the denominator, and the energy's in the numerator, and that's your energy density. So that's how we are able to get to around 10 to the 12th or so in that arc that is being created.
Yeah,
And the laser
so-
beam is passing right through it. So there is some change happening that's causing the fringes to move. And we ruled out vibrations. We've ruled out shock waves that are being created by the formation of the spark itself. And I believe through all of our efforts have ruled out instantaneous change in index of refraction. And in our paper it goes into all the reasons why we believe that. And, we're left with space-time distortion as being the reason why those fringes change. EMP won't do that, won't cause the laser to move. So, those are the things that will, and we've eliminated everything we believe.
No, this is so exciting. And if I'm doing the math right in my head, right, but just again for the audience, who may not be familiar with it. So 400,000 volts, if you're doing, I think you said it was about half an amp, you would be, in theory, if that was continuous, you'd be talking about something like 200,000 watts. But since it's a spark gap, right, it's not going to be continuous. You're
Right.
going to have sparks.
Right.
And so as those sparks happen, you're actually using a lot less wattage.
Yes.
So,
Yeah, definitely. But the energy that's instantaneous energy that's formed there and over that small volume, that's the key. And frankly, just nobody, to my knowledge, has thought to take an interferometer and measure if there's any sort of variation, by having a spark gap across the interferometer. Nobody thought to do that. So yeah.
One thing I absolutely wanted to jump into was I have interviewed Dr. Jack Sarfati, who got really into the idea of using gravitational metamaterials. And he is very much a theoretician. And one of the things he'd said is, the gravitational permeability of space and the way that it reacts to the gravitational force, right, geometry changes, is all calculated in vacuum, in free space.
Yeah.
And those are different in materials. And so he is proposing that you could potentially amplify this effect, but maybe many orders of magnitude within a material. And so therefore, you, like the skin of your spacecraft, right, would actually amplify the Alcubierre drive. Do you think that this is, in some ways, this seems reminiscent of what you did with that glycol?
I agree, because when I've been thinking about this, because let's just say what I'm doing is index of refraction changes, right? Well, index of refraction is basically related to the permeability and the permittivity of the material. And if you're getting changes there, then okay, you would see light change and bend and all that. And we've been trying to wrestle with this question is, what's the difference? Because if you say, all right, well, I'm out in free, quote unquote, I see the air quotes for those who aren't listening, who aren't watching. If you're out in free space and something changes that bends light, you could associate it to a change in the material, but there's no material change. It's free, space has changed. So how do you actually tell the difference if there's an instantaneous material property change or a change in space and time, because we derive the speed of light and refraction index, all that stuff, from the material properties, which we've boiled down to permeability and permittivity of the material, whether it's free space or whether it's some material. So, I mean, you're probably right. If you had material properties interacting with certain types of fields, yeah, you'll probably see that. So I think he's on to something. I think we're on to something, and it may even be something that brings together electromagnetics and gravitational stuff in a coherent way. That could be what's here too. I hope so.
Well, so one of the things that I absolutely had to ask was, as you know, you've presented at the APEC conference in the past. I moderate that conference every month. So one thing, I'm going to jump the gun and ask if you want to do a presentation when the paper comes out. But the other thing I wanted to ask is, there are a lot of young folks out there who are intensely interested in this area. Yeah. Are you looking to work with people? Are you looking for people to get involved?
Well, yes, on both things. I mean, as far as a presentation, be more than happy. Matter of fact, I would look forward to, because, it's a paper's out. I'm already putting presentations together around it. I've been invited to a couple of places.
I'll hold you to that then.
Absolutely, definitely. And I want people to ask the questions and pull it apart, and because I just want to know, are we really on to something, or is it something else? But if it is something else, we've had a lot of smart people, some of the people that have been a part of your group and others who have looked at it and, can't say, oh, that's just this or that's just this, so that's that. But yes, absolutely working with people. I certainly am not haughty enough or arrogant enough to think I'm going to solve the whole warp drive and space-time distortion issue myself. I'm trying to just open up some cracks in the door, and other people can help. Let's push it open and let's see what's there. And I'm already doing that. I mentioned Philip Lenz, also a guy named Greg Hodgkin, who has put together a group who's looking at it from I shouldn't say more interesting way, but another interesting way, and that is, could we utilize this to stabilize fusion reactions by controlling where the neutrons go and stuff like that. That's a very innovative way to look at it that he and his team has developed, and they want to see if this is a way to do that. So we're working with them as well, and so I definitely want to work with people. We're trying to raise some additional money from the National Science Foundation to fund expansion of this work, which they funded this first thing. So imagine that. You've got a reputable scientific U.S. organization that's funded the development of warp drive.
I want to put a good word out for Greg Hodgkin, because he is also very Star Trek motivated, right? I think he's memorized the entire series. Yep. I've done several podcasts with him. He is an absolutely brilliant, multidisciplinary person, right? Yeah. He knows many, many different areas of science, technology, and sociology. Yep. But he's a wonderful science organizer. Right. He is a group manager, brings people together and gets things done. And it's wonderful that you've been working with him.
Yep. He's brought a great group of people together that even early on, when I was talking about the earlier stuff I was doing, that's when I started, bouncing stuff with him, and then got kind of drawn into the group he was working with, and so on. So no, definitely, and we need more people like that are willing to say, all right, let's kind of come together around something and try to let everybody benefit and get whatever they're looking for out of a collaboration, but then also have a specific goal in mind. I think that's what he's been doing. And I like working with him. And as a matter of fact, Philip Lenz, who I mentioned, is been working with them as well. So he's kind of drawn people from a few different areas around a similar thing. So yeah, he's a good guy.
Yeah, it's exciting, and being able to work online, right, leverages, I think, these economies of scale as
Yeah,
well.
yeah.
And in some ways, one of the things that I've seen is this new school approach to science and technology is it's slowly coming together in an associative way, the same way that like the IEEE formed, almost a
Yeah,
century ago.
that's a
Right?
good point.
So,
That's a good point.
yeah,
And unfortunately, it took COVID to kind of create that, and I shouldn't say create it, but almost fast track
yes.
this interactivity online and everything. And we figuring it out and making it better, smoother, more and it's allowed us to do quite a bit. I like traveling though. I do like going places and stuff, but I certainly have been a lot more places online than I have been, in reality. So, it affords a lot of different things, even
Yeah.
collaboration around the world.
It's a wonderful point. I have been traveling a little bit more lately. My child is older now, so I'm able to start taking trips again. And
Yeah.
I've been packing the camera with me. In fact, I'm going to the Scientific Coalition for UAP Studies out near Jason Casibri in Alabama, out in Huntsville. And
Well,
and
that's where I am.
oh well,
When are you?
are you
When are
going
you
to drop by
coming?
the SU meeting? I think it is June 7th and 8th
Okay.
this year for the
Yeah,
2025
I'll be
conference.
back. I'll be back in Huntsville then, and yeah. I mean, if we just we've connected, so just let me know about that, and we can connect up. I didn't know about what that event was, but maybe I should.
Yeah,
find
I
out.
will send you over the info for it.
Okay.
And those events they're so important to our community. I absolutely agree. There's something that you can't replicate with Zoom online
Yeah,
that you get
yeah.
in person.
That's true.
But the other side of this that I've noted is, especially when you get into things like warp drives, right? The expertise is spread out over the entire world. And so the folks that you work with may be located, on different coasts, in different countries, different sides of the planet. And so there is, no matter how many conferences you do, there is an advantage to that online environment because you can get
Oh, yeah.
everybody together
Oh,
in
yeah.
one place.
I mean,
So,
there's people I've been working with for quite a while who I've never met in person. I mean, just have seen them online and we talk and all that. So yeah. I mean, we do need to continue to work together. There's something there. I mean, you mentioned UAPs and UFOs. Look, it's pretty well understood and appreciated that there's these things flying around out there. So we can get beyond that. And if they're doing some of the things of the observables, I know how Puthoff talks about, then these 5 observables. If they're doing these things, then there's got to be a way they're doing it. And we may be scratching the surface on some of these ways by our, kind of rummaging around in a scientific and engineering drawer to, figure stuff out. We may be scratching the surface on some of those things. But there has to be a way that they're operating in the way they're operating, whatever they are. And so that is what piques my scientific and engineering interest, is just how is it being done, and once you start thinking that way, then that's the way I've gotten to the experiment I've gotten. I wouldn't have just thought of it just like that. I started this other thing, didn't have enough energy, say, okay, how can I get a lot of energy into a small space? Let me try this, and that's what led me to here. Now, in the end of it all, it may be something completely different than what I'm doing, but it takes you down the path. And however these vehicle craft are doing what they're doing, there has to be some sort of scientific explanation. We just don't necessarily have it yet.
I'm right there with you. And I think it's one way to look at it, right? Because people go back and forth on it. Some people, myself included, tend to believe that these are some kind of vehicles using advanced propulsion, right? And I think by necessity, that means that they are non-human in origin. I I can't profess to know any more than that, but that's what it seems like is going on. That's what it seems like the government has supported. And if that is the case, then my mind goes to warp drive, because that's the only thing that explains this reported flight performance that we keep seeing report after report of.
Now, remember when we talk about warp, and so we spend a lot of time talking about the space, but we don't always talk about the time. And if you're able to manipulate space-time, you can manipulate time as well. I think there's some schools of thought where these could be people from our future who have, come back with advanced stuff and are kind of scoping around. That's one thing as well. And then there's the alternate dimension, which is also another scientifically supported notion through quantum mechanics, that there are alternate realities or dimensions that are threaded off because of our decisions and things like that. So there's a lot of stuff. Then you've got the people that think we're all in a simulation, right? So
that came to mind the other day. If we're in a simulation, all bets are off, right? Because maybe they're just using the cheat codes. That kind of popped into my head.
Exactly.
I was like, what if there's no warp drive? What if they're just typing in the cheat codes? They're like, okay,
it's easy to say cheat code, but the cheat code is doing something in the whatever the reality. It's like what we're doing now. I use pixels on a screen, but it looks like me talking and moving my mouth and all this stuff. But these are just pixels that are either turning red, green, or blue at a certain intensity at a certain spot on this screen. That's all it is. But you see everything I am and everything around me. I see you and your beautiful tie and everything. That's, so it's still a thing that's being done. It's just not in our reality. It doesn't conform to what we think physics is. But if there's a programmer out there, they may be operating under something completely different.
This dream to strive towards, it reminds me of a quote from 2001: A Space Odyssey. The movie, when the movie came out, they did a series of interviews with key figures, including Arthur C. Clarke. They were on the DVD special edition. And there was one where a reporter specifically asked him about anti-gravity propulsion, I think because it was still in the headlines more at that time. And his response was, he said, if mankind wants anything badly enough, it usually gets it.
Yeah.
Right?
Yeah.
And I
agree with that. And it kind of opens this idea of, okay, is it we just end up cracking the scientific code, or is it just that, okay, we wanted enough, okay, now the programmers say, all right, let's kind of steer them in that direction. Let's give it to them. Yeah. I mean, I don't know. I mean, I just look at the ability we have to model and create worlds within and we're just at the 21st century level of knowledge. Imagine as our abilities grow, and quantum computing and all this grows around creating realities within computerized systems. It could be just very complicated simulations, but because why do we have, why is a Planck length the farthest you can zero into, and why is quantum mechanics and quantization of energy and all this kind of stuff? Why is it like that?
You mentioned multiple dimensions a moment ago, right? And that was something, it's been a science fiction staple for decades, if not longer.
Yep.
I saw an article that supports David Deutsch's model of the many worlds hypothesis.
Right.
And they were saying that quantum computing is proof of that.
Yeah.
Now, if that is the case, and I've heard that before, the idea that when that qubit flips, it can only make basically when you measure the qubit, it's only a binary 1 or 0, but it's calculating across an infinite number of realities to get the correct answer.
Yeah.
And if that's the case, simple experiments can lead to groundbreaking achievements. The spark gap that you're working with right now could be exactly the same. A simple experiment, the bare necessity to show that something is happening, and then that can be built upon over time. That could become a warp drive.
Yeah, I mean, and that's how it works, and a lot of times, and I'm not going to just stand and with my here and just say definitively, yes, Eureka, I've done it, but everything points in that direction for me so far. And so something is happening, and it's a very repeatable experiment. Anybody could do it with the right setup. So it's not like I just saw something and nobody else could see it. And I've done it over and over again. I got tons of measurements that's on video as well as what's reported in the paper. So, people can do the experiment and make up their own minds. I'm about to do some stuff within a vacuum chamber. That's going to be next. Okay. Also going to do some a pendulum type experiment to see if there's any thrust that occurs within the vacuum. And also I have some different structures and architectures for the spark because I want to get some rotational motion of the spark formation to add that rotational element to it, which I believe can increase the performance. So I want to do all of that, and that'll probably be the next series of papers or report on and all of that. So yeah, it's going to be some interesting time, and hopefully as this summer into June and all that, I'll start getting into all of those things.
That's amazing. That's amazing. Again, Chance, I am so excited to be able to share this with people. Yeah. I'm excited. You have a paper that's coming out for publication. Yes. You have experimental data and results that you are going to be sharing more of in the near future. And you are going to be building upon this. You're going to be doing more enhanced experiments as time goes by. It's just going to keep building and building on itself.
That's right.
So let me thank you so much for your time today. Again, it has been a true pleasure and honor to have you with me.
Thank you,
Let
sir.
me close by asking, what is coming up for you in the very near future, in the next month or so? What do you see with this experiment?
Well, if you can indulge me, can I put one other technological thing?
Yes, absolutely. Go for it. Go for
it. And go to our website, morningbirdSpace.com. We've introduced something called the AppBot, and I'm an educator as well. And I really care about STEM education, getting people interested in it who might not necessarily think they're interested. Well, this robot that we've designed is a 3D printable robot. Now, as you can see here, and there's the head because it attaches and doesn't attach. But this thing can be 3D printed and assembled, and it's a fully functional humanoid robot. And its goal is to teach STEM to those key elements. So think about, obviously, robotics, CAD design, 3D printing, coding, engineering and electronics, then teamwork, getting students to work together. This is like a curriculum type thing that we're pushing out to schools for whether it's K through 12, universities, community colleges, who can use this as a way to teach those skills in a way that is fun and everything else. Everything is available on the site, the tutorial videos, the documentation you need once you purchase, all of that is there. But we're trying to get excitement in STEM so that we can get more and more people doing the stuff that we're talking about here. Because we need to push this generation forward more and more, studying STEM and doing things in science, technology, engineering, and math. And this is one way to do that. So thank you for letting me introduce that. And if anybody can help us and support us, just purchase online. It's a kit that is less than $400 for the kit. And a student can just learn and do all this stuff.
Okay, well, that is a perfect note to close on then.
Okay.
Thank you for sharing that. So what I will do is put a link into the website so people can learn more about it.
Thank you.
Again, getting young people involved in STEM, and they can learn more about your advanced research there as well.
Yes.
So Chance, thank you again so much for your time today, sir.
Tim, thank you, sir.